In this lesson, we're going to learn how to simplify radical expressions. Okay, so some things we should know before we actually get into the lesson. Any base raised to the 1/2 power is the same as taking the square root. So as an example, if you have 9 to the 1/2 power, that is the same as the square root of 9, which is 3. All right. Another example, if you have, let's say, 49 to the 1/2 power, that is the same as the square root of 49, which is 7. Okay, because 7 times 7 will give me 49, which is right here. You multiplying it times itself. And 3 times 3 will give me 9, because you're multiplying 3 times itself. So let's look at the cube root. Right here, any base raised to the 1/3 power is the same as taking the cube root. So as an example, if I have 8 to the 1/3 power, that is the same as the cube root of 8. So what number can you multiply 3 times itself to get 8? That is 2. So the cube root of 8 would be 2, because 2 times 2 times 2 is 8. If you have, let's use 343. If you have 343 raised to the 1/3 power, that would just be 7, because that is the same as a cube root of 343. And you're asking yourself, what number can I multiply 3 times itself to get 343? That is 7, because 7 times 7 times 7 is 343. All right, so let's look at these first two examples here. We want to simplify the cube root of 27. Now, the first thing you want to ask yourself is this a perfect cube or a perfect square? Because we have this index here of 3. So let's look at our list. And yes, it is a perfect cube. It will help to write this list in your notes, or you can learn how to generate perfect cubes. So in order to do that, you will just take each number in sequential order and multiply it times itself 3 times. So 1 times 1 times 1 is 1, so that's a cube root. 2 times 2 times 2 is 8, so 8 is a cube, perfect cube. 4 times 4 times 4 is 64, so that is a perfect cube. So that is how you generate cube roots. So since 27 is a perfect cube, my answer would just be 3. Because 3 times 3 times 3 is 27, and that is it. All right, so now let's look at the next one here. We have 24 to the 1/2 power. First, we want to rewrite it using a radical. So remember, anything to the 1/2 power is the same as taking the square root. So that 2 goes away. That's the understood 2 in front of the radical. Now, ask yourself, is this a perfect square or a perfect cube? Looking at my list here, no, it goes from 16 to 25. So 24 is not a perfect square. So then you want to ask yourself, what are some factors of 24, and one is a perfect square? So we want to find 2 factors where one factor is a perfect square or perfect cube. So in this case, since this is a square root, we want to find 2 factors of 24, and one factor is a perfect square. So let's think. 8 times 3, 8 and 3, neither one of those are perfect squares, but we do have 4 times 6. And you want to think of your largest perfect square that's a factor. 4 times 6 is 24, right? And 4 is a perfect square. Okay, and so I've done this part. So now I just want to simply take the square root of the perfect square. So the square root of 4 is 2. Bring that on the outside of my radical and leave the 6 underneath, or the imperfect square underneath. And so that is my answer. Always check to make sure that underneath your radical you don't have any factors within that number that's a perfect square. Because if you do, that means you didn't choose the largest perfect square. So you need to choose the largest perfect square. All right, so just to recap, find two factors of the number, and one is the perfect square. You need to choose the largest perfect square. Take the square root of the perfect square. So in this case, it is 4. The square root of 4 is 2. And I leave my imperfect square under the radical. So that 6 stays underneath the radical. And I read this as 2 times the square root of 6. Okay, so let's take a look at these two. So example 3, we want to find the square root of 12 or simplify the square root of 12, right? First question, is this a perfect square or perfect cube? So in this case, since we're just looking at the square root, we're checking to see if it is a perfect square, and it is not. All right, so next we want to find two factors where one factor is a perfect square. So my factors of 12, 6 times 2 is 12, but neither one of those are perfect squares. So I would have to use 4 times 3 because 4 is a perfect square. And the square root of 4 is 2. And I leave that 3 underneath the radical. So I've simplified this radical expression. Once again, we could not use 6 and 2 because 6 nor 2 is a perfect square. Let's look at example 4 here. The first thing we want to do is rewrite using a radical. And so 2 is my index. So if you need a review on rewriting rational exponents to a radical, please see my video, Rational Exponents and Rational Expressions, and I will link it at the end of this video. All right, to get a refresher on that. So this 2 is my index, that is in my denominator, so that goes in front of my radical. 5 is my base, and then my 3 is my exponent underneath my radical. So now remember, we do not put 2 here. So again, you might want to reference my video I just talked about. We do not put 2 here. So we would rewrite this as 5 to the third, because when you take the square root of something, it is an understood 2 in front. Okay, so we don't put that 2. Now, since I have the square root of 5 to the third power, let's simplify that. What's 5 to the third? That is 125, right? So now, 125 is not a perfect square, but I want to find two factors of 125, and one is a perfect square. Well, anytime you have 5 on the end, a helpful hint would be to think about 25. 25 times 3, that gives me 125, and 25 is a perfect square. So the square root of 25 is 5, and I leave that 3 underneath the radical. So I have simplified this rational expression and made it into a radical expression. Alright, so I would like for you to pause the video and try these on your own. Take note that you have the square root of 32 and 360 to the 1/3 power. So go ahead and pause the video and try these two problems on your own. Alright, so hopefully you got the answers correct here for square root of 2. For the first one, we could break up the 32 into 16 times 2, and the square root of 16 is 4. So that is my final answer. The second one here, that is the cube root. So you try to find two factors of 360 where one is a perfect cube, and we could use 8. 8 times 45 will give me 360, and the cube root of 8 is 2. And I have to bring over that index of 3, and 45 would be left underneath my radical. Alright, so hopefully you got those correct, and if you did not, hopefully you understood what you did wrong or incorrectly. Alright, so what do we do when our base is a variable? Well, some things to note. If a variable has an even exponent, then it is a perfect square, and to take the square root of it, you simply divide by 2 or take half of that exponent. But what if your variable is a multiple of 3? Then it is a perfect cube, so you would just take the cube root by dividing that exponent by 3. And remember, this is just referring to the exponents. So let's try a few problems. Alright, so let's take a look at these two examples here. We have variables for our base. So if you notice, our first one right here, we have an odd exponent. So what do? Well, since we have an odd exponent, we simply subtract 1 from the exponent, or separate it, and then take the square root. So what I mean is 5 minus 1 is 4, so I can rewrite this as x to the 4th times x to the 1st. And we don't put 1 for an exponent, so that's x to the 1st. So now I have my perfect square, and I have an imperfect square. So just like if you have a number, you want to take the square root of the perfect square. So the square root of x to the 4th is x to the 2nd. And I leave my imperfect square under the radical. My imperfect square is x to the 1st, and so I simply leave that under the radical. Okay, so just to recap, if you have an odd exponent, subtract 1, and then take out one of those bases there, and leave that imperfect square under the radical after taking the square root. All right, so now let's take a look at the second one here. We have 16, x to the 3rd, y to the 4th, all underneath a radical. So let's rewrite it, break up this odd exponent here. I'm going to bring down my 16. I could rewrite that x to the 3rd as x to the 2nd times x to the 1st. Same thing I did with example 5. So I subtract 1 from my exponent and write another base with the exponent of 1. Y to the 4th is a perfect square, so I simply bring that down. Now I just want to take the square root of all of my perfect squares and leave everything that is not a perfect square underneath the radical. All right, so the square root of 16 is 4. The square root of x to the 2nd is x to the 1st. Remember, we just divided by the exponent by 2, so that's x to the 1st. This x is not a perfect square, so I would leave that underneath the radical. And then y to the 4th, I would just divide that 4 by 2, so that would be y to the 2nd power. So I've simplified this radical expression. So once again, to take the square root of your exponent, you simply divide by 2, and of course it has to be even. If it is not, you would rewrite it by subtracting 1. Okay, so let's look at this last example here before you try a few on your own. So we have a fraction with a rational exponent. So the first thing we want to do is simply simplify the numbers by dividing. So let's simplify this fraction. So we have 81 divided by 3. That is just 27. All right. All right. And then, oh, that 27 is ugly. Let me rewrite it. 27, a little better. All right, and then we have x to the 4th divided by x to the 1st power. So now you have to remember your exponent rules. If you're dividing with the same base, what do you do with your exponents? Well, that quotient rule tells us to subtract. So 4 minus 1 is 3, so that would give me x to the 3rd. Same thing with y to the 5th and y to the 2nd will give me y to the 3rd. So I'm subtracting my exponents. All right. So remember, anything to the 1/3 power is the same as the cube root. So let me rewrite this using a radical. All right. So now we have the cube root of 27x to the 3rd, y to the 3rd. Now, is 27 a perfect cube? Yes, it is. The cube root of 27 is 3, because 3 times 3 times 3 is 27. All right, then I take the cube root of x to the 3rd, and remember, if it's a multiple of 3, you simply divide by 3. So 3 divided by 3 is 1, so that leaves me with x to the 1st, and then y to the 3rd, I divide again by 3, that would be y to the 1st. So my final answer is 3xy. Okay, I would like for you to try these two problems on your own, so go ahead and pause the video and simplify these radical expressions. All right, so go ahead and check your answers here. Hopefully you got them correct. If not, I'm just going to review a little bit. So that 12 is not a perfect square, so I can break that up into 4 times 3. I can rewrite that h to the 5th as h to the 4th times h to the 1st. And then that k to the 2nd is a perfect square, so I just bring it down. So now I want to take the square root of all of my perfect squares and leave the imperfect squares under my radical. All right, so the square root of 4 is 2. This 3 stays underneath because it is not a perfect square. H to the 4th, the square root of that is h to the 2nd. This h stays underneath the radical. K to the 2nd, the square root of that is just k. And so this is my final answer. The last one here, of course, you want to rewrite it with the radical because remember, anything raised to the 1/2 power is the same as taking the square root. And then I simply divide and then subtract my exponents. And then from that point, I could break up this 20 into 4 times 5. All right. The a to the 3rd is not a perfect square, so I can break that up as a to the 2nd times a. And b to the 6th is a perfect square because it is a even number. All right, so the square root of 4 is 2. 5 is not a perfect square, so that stays underneath the radical. A to the 2nd, the square root of that is a to the 1st. All right, this a is imperfect, so it stays underneath the radical. And b to the 6th, we take half of it or divide by 2. That will leave me with b to the 3rd. All right, so hopefully you got these 2 problems correct. And if you did not, hopefully you understand them a little better right now. Okay, so we reached the end of our lesson. I want to thank you for learning with me. Some related videos are listed below right here. And if you would like, you could like the video, comment, share, and subscribe. And again, I want to thank you for learning with me.